All right, for number 12, we have x is greater than or equal to -4. Now, greater than or equal to, this is going to be a solid line. And I call this vertexal because any x equals is a vertical line. So all the x coordinates here are -4. -4, 0, -4, 1, -4, 2. All the x coordinates are -4. All the y coordinates change as you go up and down the line. So that should be a solid line. Maybe it's a little too rough. Horizontal line at 1. So I'm going to do a little dotted line here because this is going to be less than, not less than or equal to, so none of the points on that line. Now, if I'm greater than -4, I'm going to go to the right. If I'm less than 1, I'm going to be below. So the overlap to satisfy both of those inequalities is going to fall in this shaded region here. All these points would satisfy having an x coordinate greater than or equal to -4 and also a y coordinate less than 1. Okay, solve the system for number 13. This is a 3 by 3, 3 equations, 3 different variables. What I'm going to choose to do for this one is elimination. If you wanted to use substitution, it would be really easy to get x alone in the first equation, but I'm going to go ahead and use elimination here as my example. I'm going to take, you have lines 1, 2, and 3. What I'm going to do here is I'm going to multiply line 1 by 3 and match that up with line 2. And then I'm going to multiply line 1 by 8 and match that up with line 3. Both of those to eliminate the x. And I'm just going to do that while the video is paused to save some time here. So here's 3 times line 1 matched up with line 2. I'm going to eliminate the x's. I'm going to add these. 3 and -3 is 0. That eliminates x. This would become 9y, 22z, and 7. Over here, 8 and -8 cancel out, add up to 0, eliminates that. Make sure you got to eliminate the same variable, because if you don't, you're going to create a different problem for yourself. So I eliminated x. This is going to give me 21y plus 52z equals 19. Now, this is tricky, but you have 2 equations with 2 variables. The unfortunate part here, you're not multiplying 9 by anything to get 21, and you're not multiplying 22 by anything to get 52. So I'm going to have to multiply both of these lines. I'm going to multiply one of them by a negative number, so I'm going to do -21 here, +9 here. Those will help me eliminate the y, and I'm going to pause it again here just to save some time on the video. Okay, here when I do my elimination, these are going to go added together, the z's. This actually simplifies to just be 6, and then -147 plus 171 is 24. So the z value here of the intersection is going to be 4. And then you just start plugging that back in. You can plug it into any of the equations. 21y plus 52 times 4 equals 19. So I would do 19 minus whatever 52 times 4 is. And I'm going to get 21y is equal to -189. So then y is -9. And then if I plug that back into the original, then we can get, and you can pick any one of the 3 equations. I'm just going to use the one at the very top here. So x plus 2 times -9 plus 5 times z, which is 4, equals 1. This will be x minus 18 plus 20 equals 1. So x plus 2 is equal to 1, so x is equal to -1. Now, we should write our answer as an ordered triple. That means the x goes first, the y goes second, and the z is third. So that would be my answer for that question. For number 14, I'm just going to use some synthetic division, and I'm going to do the opposite of this. If you want to use long division, you can. I'm going to do a quick spot check, make sure I'm not missing any powers of x. So I'm not, so I'm going to write down my coefficients here. And we just go ahead and bring down the first term, multiply 2 times -2, that goes in the next open space, and then we add here. 2 plus a -4 is -2. 2 times -2 is -4. This is going to end up being -11. 2 times -11 goes in the next open space, which is 22, and 15 plus 22 is 37. Now, this is your remainder constant and then start adding powers of x. So if I divide that, we're going to get negative 2x squared minus 2x minus 11 with the remainder of 37. Solve the system. I would say easiest thing to do here, I'm just going to take this guy and multiply it by negative 1. That'd give me negative 2x plus 4y equals negative 12. Eliminate the x's there. Negative 1 plus 4 is 3. Negative 3 plus negative 12 is negative 15. Y would end up being negative 5. And then I just have to pick one of the equations to plug that back in. I'll just go with the first one. This is 2x plus 20 equals 12. So if I subtract the 20 from both sides, we're going to get negative 8. And divided by 2 would be negative 4. So my intersection of those two lines is negative 4 and negative 5. And you know what, guys? I just realized a teeny mistake. When I was right here, this should have been negative 22. And so this is 7. So let me just change this real quick. That remainder on number 14 should have been 7, not what I had as 37. Okay, on to the next. For the polynomial function pictured, we're going to state intervals of the domain for which the graph's increasing and decreasing. Okay, so as I go from left to right, as I'm tracing the graph, if you're going up, like I am here, I'm increasing, and then I get to this point, and I'm not increasing or decreasing, I'm just kind of flat, and then I switch over as I'm tracing, and now I'm going down. So I'm decreasing until I get to this point, and then I'm flat again. I'm not increasing or decreasing. And then we switch over here, and we're increasing. So we have 2 increasing intervals and 1 decreasing interval. These are always x values because it's over the domain. So as I approach from negative infinity, I'm coming from this way. This graph is increasing until you get to the x value right here. Very important. It's the x value. Okay, so this interval right here will be from negative infinity to that negative 3.667 x value. Okay, then I'm decreasing. So I pick up right here. I'm not increasing or decreasing at this x value. We're just flat. So from that negative 3.667, decreasing, 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 till I get over to this x value, which is 1. Do not use the y values. And then at the x value of 1, then we switch over and we start increasing again. So the rest of the graph, and I know this is going to look like I'm going up, but I'm going to the right. So from 1 to positive infinity, the entire time I'd be tracing this graph, it would be increasing. So your 2 intervals of increasing, negative infinity to negative 3.667 and 1 to infinity. Your only interval of decreasing right here, negative 3.667 to 1. Okay. Model for a company's revenue from selling a software package is given by the function here. R is negative 2.5 p squared plus 500p, where p is the price in dollars of the software. What price will maximize the revenue, and then find the maximum revenue? Okay, now if we were just to graph a sketch of this quadratic function, we would know that it would turn upside down because of the negative in front of our leading coefficient here, the negative 2.5p squared. So if they're asking for a maximum, they're literally just asking you for the vertex of that graph. Now the way this is laid out, the price would be your x-coordinate, and the revenue would be the y-coordinate of the vertex. So all we have to do for x-coordinate of the vertex, negative b over 2a, for this question, that would be negative 500 over 2 times negative 2.5. Now, I know I've said this a lot, so I'm just going to reiterate this. If you're doing this question, I would do negative 500 and then divided by, I would put this in parentheses, okay, so 2 times negative 2.5, because I need to do that product first. If you don't put that in parentheses, it's going to divide 500 by 2 and then multiply the result, which is not what we want. So this should simplify to be 100. That's going to be your price. And then your revenue, we're just going to plug it into the formula. So negative 2.5 times 100 squared, and then plus 500 times 100. Whoops. Just plugging that price in. And your revenue here is going to be 25,000 for that question. Okay. Find the y-intercept of the graph. Don't anybody be writing 7. Okay, Y-intercept means you're crossing the y-axis, so the x value has to be 0. So what you want to do here, the y-coordinate of that point, is to plug in 0 for x, and then simplify this. I'm just doing my order of operations. 0 minus 1 would be negative 1. If you square negative 1, that becomes positive 1. So really all I have here is 2 plus 7, which would be 9. Now that's the y-coordinate. The actual point would be 0, 9, because we plugged in 0 for x. But anytime you're finding a y-intercept for any graph, plug in 0 for x and solve. And the last one on this page, we're just going to do a FOIL. 4 times negative 3, negative 12, and x times x is x squared. 4 times negative 5 is negative 20x, and 1 times negative 3x is negative 3x. 1 times negative 5 is negative 5. Go ahead, combine your like terms. Negative 20 minus 3 is negative 23. And then in terms of your identification, your quadratic term is going to be negative 12x squared, your linear term is negative 23x, and your constant term is negative 5.